All right, for all those people that are here and happy to be here. Are you ready? Yeah, as you're gonna be. Danny, you ready? You ready? All right, class. Okay, all right. Could have been better. Could have been better. All right, so we're gonna go through. We're continuing 5.4. This is actually bounds on an integral. So from here, if you look at my shaded, and what I'm trying to show here is I'm trying to find from here if f is a function is continuous on a closed interval from a to b, that's down here, a to b, and m, little m, and capital M denote the absolute minimum, which is my little m, my absolute maximum is my big M, and the absolute maximum value, respectively, of f on the interval from closed interval from a to b. Then, so this right here, minimum, right? Minimum, b times a, or b minus a, should be less than the integral right here, which should be less than the capital M, which is my maximum of b minus a. So my integral, my actual, this piece right here, which is my area under the curve. That's all the shaded part right here. That should be all the shaded. So this right here should be more than this down here, which should be the area here, should be less than right here. Should be less than all of that there. Does that make sense or is that nonsense? Minimum? Are you guys okay with minimum? Yes, Denny? Minimum. Okay, there's a minimum. Maximum. Right here, right? So way up here is my maximum. Okay. And then my integral should be between, somewhere between there. Remember when we did the mean value theorem, where the average should happen somewhere in between the certain points of a closed interval, so it should be somewhere. So at some point I need to cross the road. So if I know that I started out on this side of the road and I ended up on that side of the road, at some point somewhere in between I should cross the center of the road. I don't know where, but in my interval from A to B, somewhere in between those two, I cross that road. Does that make sense? Is that better? Kinda? Chicken cross the road. Yes? Okay. Is it a case of the Mondays? Is that what it is? Everyone's still hungover from that 5-day weekend you guys had? Since most people didn't come in yesterday. I say most. Like, yeah. Then you had the 4-day weekend because not too many people do anything on I-days. Did you go to work, Danny? You don't go to work? On your, not on your, you quit?
Yeah,
How dare?
it was too much.
Did they disrespect you? They did not respect your authority, right? Okay. All right. So, find an upper bound and a lower bound for the area under the graph of this function right here from 0 to pi. So, let's go through item by item. So, upper bound, lower bound for the area. So now, here's my area from 0 to pi. So, my integral is going to look like this. 0 pi sine x dx. So if I were to graph that from 0 to pi, Now, think about your unit circle. Unit circle, what is the sign at 0? That's cosine. Remember, unit circle starts off on the right-hand side, right here. So it goes 0, comma 1, right? Sine is my y value, isn't it? Okay, up here, this is going to be 1, comma 0. Did I have that backwards? Yes, I do. How dare I? Ah, dang it. Okay, my whole thing just closed. And everything stopped working. It's 1, 0. So the sine at 0 is 0. The cosine at 0 is 1. God dang it. Did I lose my whole slide? Yes, yes I did. I lost my whole slide. So it was sine of 0 to pi. And then my graph is going to go like this, starting at 0. Wow, that is a horrible line, not even close to straight. So, sine at 0 is 0, sine at pi is 0, sine at pi over 2 is 1. So, this graph is going to look like this. From 0 to pi, from there to there. All right, my lowest point here is going to be where? 0, right? So for this one right here, this is going to be 0 times b minus a, which is pi, minus 0, should be less than equal to the integral from 0 to pi sine x dx, which should be less than equal to, what is my high value here? What is my highest value? At pi over 2, that's the x value, but I'm with the y. It's going to be 1. So it's going to be 1 times my pi minus 0. So what this is saying is, all this is going to be 0. It should be less than equal to my integral from 0 to pi sine x dx should be less than equal to pi. So it should be somewhere in between there. Does that make sense? So we have that in between those two. Now, let's do my sine of x. What is the integral or the antiderivative of sine of x? Negative cosine x. So that's going to be negative cosine x from 0 to pi. All right, so what is cosine at pi? Isn't pi all the way on the left? Negative 1. So this is going to be a negative times negative 1 minus my lower bound which is going to be right here. So what is cosine of 0? Positive 1. So it's going to be positive 1, but because there's still that minus sign out front, that's why it's Gonna get that. So do the math. Negative negative makes that a positive 1 plus 1 equals 2. So for this to be true, I have that 0 is going to be between, I'm sorry, 2 is going to be between my 0, which is my pi. Is that true? Yes. Pi is 3.14. So 2 is going to be between there. So that is going to be a true statement on that one. So we're finding the minimum, the maximum, and it is going to be somewhere in between there for those values. Yes, no, maybe? Did it look just overly complicated at first? It's not too bad, is it? I think the hardest thing that you guys are going to have to figure out is the maximums here. Okay? Because I have minimums, maximums for each item. Okay, work with the mean value theorem. So, suppose f is a function is continuous and non-negative on a closed interval from a to b. This figure down here suggests that the area on the graph from a to b, the integral here, f of x, is equal to the area of some rectangle of the width from b to a and the height of u for some choice or choices of u in the interval. So let's see if this actually makes a little bit better sense now. They're saying that the integral from a to b is going to be equal to some, so this is the integral right here. So area under this curve is going to be equal to some value. Let me throw a purple in here. Why not? Is that a purple? Yeah, that's close enough. It's going to be equal to some value that is just a regular rectangle. So this, the height, is going to be f of u. The height is going to be f of u. It's some function that I could plug in here to give me my height, and my width is going to be from a to b. So we're going to find some value of that for that to work out. And f of u is some point on my graph where I could actually average that out. Maybe, kinda. So let's do the math on this. So if a function f is continuous on closed interval, there's a real number from that u is between here from a to b, for which right here I'm going to find some value for this one right here. So we are going to have from something, we're going to have to find this one here. So if we find our interval, let's say that we know that this is equal. If I know that this is equal, can I do some algebra from here? Say yes. I could do some algebra. What if I know what the area under the curve is? Let's say the area under the curve is 10. If I know that this piece right here is 10, and I know it's supposed to be f of u is going to be times b minus a, if I still want to try to find what my f of u is, what would I do with my b minus a to get my f of u by itself? Just a little bit of algebra, right? I'm just going to divide by b minus a. I would just divide that by b minus a, and that's going to give me this value so I could solve for u. Find the numbers used guaranteed by the mean value theorem for the integrals from 2 to 6 x squared dx. So, I go from 2 to 6 x squared dx, and I know that's going to be equal to some f of u, which is the value somewhere on there, and that's going to be times my b minus a, which is 6 minus 2. So let's take my integral, do the integral. So the integral of x squared is going to give me, very good, x cubed divided by 3. And that's my bounds from 2 to 6. Let's go ahead, plug those in. So 6 to the third. I don't know that one from the top of my head. Six to the third, like 218, 216. Okay, 216 over 3. That's going to be 72, right? Maybe. You guys can use your calculator. I know it's it's a bad case of the Mondays, since we had like 5 days off and having to actually math, because I really don't want to make mistakes on this, because that makes it even worse. $27, 72, 27, 27, 72. Okay, thank you. All right. So minus my lower bound, which is going to be 8 over 3, which is what's that, like 2.6 repeating? And that's going to give me 69.3 repeating. Actually, I don't want that decimal. I don't think I like that decimal. So I'm just going to keep it as 208 over 3. All right, do the math. This is going to give me 4. So 208 over 3 is equal to f of u times 4 divided by 4 divided by 4. That's going to be 208 over 12 is equal to f of u. And what is my function of f of u? What is my function? Isn't this right here my function? My function is just x squared, isn't it? So, what this is trying to tell me is I need to find where my function x squared is equal to 208 over 12. So that's going to be, let's see, And to get my x by itself, I would divide both, or square root both sides. Actually, I think I can clean it up a little before. So by a factor of 4, that's going to give me a 3. Factor of 4, that's 52 over 3. And then square root is not going to come out nicely. So x equals plus or minus the square root of 52 over 3. All right, so now look at my bounds. I have two answers that say, mathematically say they work. But look at the problem. Is one of the problems not going to work for my solution? Which one? The negative. It can't be negative, right? Because my bounds are from 2 to 6. So those are all positive, so I can't have a negative value. So my f of u, my function, so my x value, or my u value in this case, where it's going to be the height of, my x value, where my height is equal to this value right here. My height's going to be equal to that. My u value is going to be the square root of 52 over 3. And since we have the opportunity and you guys have your calculator out, what is my u going to be? And give me 3 decimals on that one. Four point what? 3 decimals. 1/6 what? 1/63. There you go. So there is my u value. And if I go back to what my diagram looked like, back over here, my u value is 4.163. My f of u right here, this is my f of 4.163, or my 52 over 3 is that value right there. That's the height of my average right there. That's where it's going to come out to be. That's the height of that. And then from B to A on my value was 2 to 6. So that's basically what we just did. Okay? So if we're going to try to find the area of a rectangle that is equal to the size of the area under the curve. Now, anyone think of an application for this? So one thing I'm currently doing, I'm actually like selling property. So my land that I have is a perfect rectangle. But then we're breaking up into different parts because we have so much land. And then what we're doing is we're actually making it into different. So right here, so what the acres is equal to 43,650 square feet is 1 acre. And when you're looking at land, and you try to figure out how much land is there, we take the whole thing and divide it by that. So it's going to be a certain amount, and then there's a curvy parts. So, was it cryptology, where they actually do maps? I guess. Okay. Anyway, trying to make it interesting. No one's actually interested in math anymore. Everyone forgot that math is a thing. Now, for this one right here, we are going to find the average value of a function. We know that from the mean value theorem for integrals that if a function is continuous, function f is continuous on a closed interval from a to b, there is a real number u for which that this actually works out. It is somewhere between there. We get this. And then the average value formula is non-negative closed interval from a to b, the area enclosed by the rectangle, height f of u with width b minus a equals the area under the graph. Right here, here's my graph, and there's the rectangle for that one. Got distracted here. A graph from A to B, see figure. Consequently, f of u can be thought of as an average value or mean value over the interval. And for the average value, we actually have a different formula from here. So average value, and the notation is y bar. That's what this is right here, y bar of f over the interval. So the average value of that is going to be there. And then we have the formula of 1 over b minus a times the interval. And we did all of that. We made that formula from all this. We got that formula. I took this out. I found out what my integral was. I set it equal to f of u, and then of my bar, then I actually divided it. So this over here was just 1 over b minus a on this side times the integral of what we had, and that's where we get my average y value. So on this one right here, we're finding my average y value on that one. And that's what we get right here. So y bar. So the average on that one. So the average value y bar of a function f equals to the value of f of u in the mean value theorem for the integrals. So let's go ahead. Find the average here on the closed interval. So now I'm going to do my y bar is equal to 1 over b minus a, which is 2 minus 0, of the integral from 0 to 2 x cubed dx. So outside my integral, it's 2 minus 0, so it's 1/2 times my integral. So what is the integration of x cubed? Denny? Very good. So it's x to the 4th over 4. I bring from 0 to 2. And then this is going to be times 1/2. So bring over my 1/2. Plug in my 2, my upper bound. So 2 to the 4th power is going to be 16. 16 divided by 4 is 4, minus my lower bound, which is 0 right here. So 0 to the 4th is 0. 0 divided by 4 is 0. And I can do my math, so 1/2 times 4 is just going to give me 2. So that means that my y bar, my average y value is 2. Before we go into all of this right here in the motion where we actually talk about going forward or going backwards and we're talking about velocities and all that, I think that one right there should be tomorrow. We'll just tackle that one tomorrow. And then everyone's gonna like, share, and subscribe, right, Denny? Yeah. You were supposed to buy stuff in the merch store, Denny. All right, so you guys can work on the assignments.